Continuing with question number 7, question number 18. Now here we have secant inverse as x approaches infinity. Now something about the secant inverse that you need to know from the property of secant and how the graph of the secant inverse looks like. Secant inverse x as x approaches infinity or negative infinity is going to be pi over 2. So you need to know this from the behavior of secant inverse. So now doing this one, I have secant inverse of this as x approaches infinity. So what I can do is I can find the limit of this first, which is the inside one. So now this is a polynomial. Degree up is 2, degree down is 1. So this is going to positive infinity. So this means that this thing here is going to be infinity. Okay, what is secant inverse of infinity? Well, from the graph of secant inverse, we know that this will be equal to pi over 2. Now, question number 19 says, find the limit as x approaches 0. Now here, they did not specify for us whether they want us to find from the right or the left. So this means I have to check both. So I will start by saying limit as x approaches 0 from the right. Then I will do from the left. Sine of e to the power negative 1 over x squared. Now one thing that you need to remember, whenever you have a number over 0, the answer is either positive infinity or negative infinity. How do I know? I know by studying the sign of this. Okay, so now look here. If I were to say 0 from the right, so this means I will substitute instead of the x squared 0 from the right. Why am I saying 0 from the right? Because 0 from the right means it is positive, more than 0. So like 0.001. So it is positive. So now let me study the sign of this. I need to know the sign of this so I can know whether this is positive or negative infinity. Minus 1 over 0 from the right squared. Now 0 from the right squared means that this number will be positive because this is a positive number and I am squaring a positive number. So what will be this? It will be positive. Up I have negative 1. Negative divided by positive will become what? Negative. So the sign of all of this is negative, which means that this will be negative infinity. So this is going to be equal to sine e power negative infinity. Now what do I know about e power negative infinity? From this question, we said as x goes to negative infinity, the e is 0. So now I will end up with sine of this thing will become 0. Now what do you know about sine 0? Sine 0 is just 0. And now we found the limit from the right. Now again, I will repeat the same thing, but now I need the limit as x approaches 0 from the left for sine e power negative 1 over x squared. Again, same like I did, I am going to substitute in the place of the x 0 from the left. Now I need to study the sign of this. Minus 1 over 0 from the left squared. 0 from the left means like 0.01. So it's a negative number. But what am I doing here to this number? I am squaring it. So what will happen to it? It will become positive. Up there's negative 1. Negative divided by positive is negative. So this thing is also negative. So now I will say sine e power negative infinity. What do we know about e power negative infinity? It is 0, and sine of 0 is 0. Now, since the limit from the right equals the limit from the left, I can conclude that the final answer is 0. Now, coming to question number 20, limit as x approaches infinity. Now, for the tan inverse, I believe, okay, tan inverse, I explained it in a previous recording. The graph of tan inverse looks like this. Tan inverse has two horizontal asymptotes that are like this. As x goes to infinity, tan inverse goes to pi over 2. As x goes to negative infinity, x goes to negative pi over 2. So you need to know this from the behavior of the tan inverse. So tan inverse as x goes to positive infinity is pi over 2. Limit of tan inverse as x goes to negative infinity is negative pi over 2. So now I will go here and I will start solving. I will say sine tan inverse of infinity. So I substitute it in the place of x infinity. What do I know about tan inverse of infinity? It will go to pi over 2. So now here I have sine pi over 2. Now how much is sine pi over 2? You can put it in your calculator on radians. So sine pi over 2 will give me 1. So the answer here is 1. Now we come to question number 21. Again, they said limit as x approaches pi over 2. They did not say from right, they did not say from left. So what does this mean? I need to check myself. So x approaches pi over 2 from right. We will do this one first. For e power negative tan x. Okay. Now I know that the tan has an asymptote at pi over 2. Now since it is from the right, are we going to positive infinity or negative infinity? How can I know this from the calculator? Very simply, all you need to do is put e to the power of negative tan x. Now click calculate. I need pi over 2 from the right. So I'm going to put pi over 2. Now what does from the right mean? It means more than pi over 2. So maybe, for example, I will add to pi over 2 0.001. Okay. I will click equal. Okay, calculator gave me error. So maybe I need to reduce the number. Sometimes if the number is very big, calculator gives error. So let's say 0.01. And I click equal. What did the calculator give me here? It gave me a very large positive number. So 2.6791 times 10 to the power 43. This is positive 43. So the answer of this is positive infinity. Now if I go and I find limit as x approaches pi over 2 from the left, for also the same, e to the power negative tan x. Okay, again I want to do this using the calculator. I will click calculate. Now I will click pi over 2, but now we want from the left, so I will subtract 0.01. So now look, what did the calculator give me? Minus 3.73 times 10 to the power negative 44. Again, I told you this before. Whenever I see a number times 10 to the power negative, a very large negative, this means that this is 0. So now look at this. Limit from the right is not the same as limit from the left. So what does this mean? That this limit here does not exist. Okay. If you want more details about this question here, look, e to the power negative tan x. What you can think is, what do I know about the tan when we are approaching pi over 2 from the right? You can say tan pi over 2 plus 0.001. So I added a little bit to the pi over 2. What did I get? Negative 9999. So this is like a what? A negative infinity. So this is going to negative infinity. And negative infinity, there's a minus before it. So what does negative and negative become? Positive. What do we know about e power infinity? It is infinity. So here I'm just giving you a little bit more details. If you understood how we got it with the calculator, that's enough. Now again, I go to the tan here. I go to my calculator. I ask myself, what is happening before pi over 2? Before it by a little bit. So I change this to minus. Again, the calculator gave me 999. So this is like a very large, big number. If I add more zeros, look, it became even bigger. It is a positive big number. So this is like infinity. Positive infinity times negative. So this one will become like e power negative infinity. What do we know about e power negative infinity? It is 0. Now I come to the last one. Tan inverse ln x, 0 from the right. So this is a straightforward. Tan inverse ln of 0 from the right. Again, from the properties of ln that I explained, ln 0 will go to negative infinity. So this is like tan inverse of negative infinity. Now what did we say about tan inverse at negative infinity? Where does it go? It goes to minus pi over 2. And that is it for question number 7.